This is part 2 of section 5.6. We're remembering how to do long division. We're just talking about the process. Okay, so how many times does 57 divide into 27,876? Okay, so we look at 57 and we want to know how many times it goes into 2. It doesn't. Does it go into 27? No. So we add another digit. How many times does it go into 278? Okay. Well, let's estimate. 5 goes into 27 5 times, so I'm going to try a 5. And if it works, it works. If it doesn't, it doesn't. Okay. So 5 times 57 is 285. 285 is larger than 278. So that 5 was too big of a guess. I'm going to drop back to a 4. Okay, now 4 times 57 is 228, which is good. If you subtract, we get 50, and then we bring down the 7. Okay. Now, let's look at the 5 and the 50. Well, 5 goes into 50 10 times, so that's definitely too big. We can only have a one-digit number, okay? All right, so let's try 9 times 57 and see what we get. 9 times 57 is 513, so that's too big as well. So we're going to go with an 8. 8 times 57 is 456. Subtract 507 minus 456. To get a 51, which is smaller than 57. Okay, so let's see, we brought down that 7, now we're bringing down this 6. So I have 516. Well, we just did 9 times 57 and got 513, so that's really close, right? That was 9 times 7, 513. So I'm going to put a 9 here. And we know it's 513, which means we have 3 left. So my answer is 489 and 3 over 57. Okay. To check, we do 489 times 57, and then we're going to add 3, and we hope we get 27,876. 489 times 57. Plus 3 does give me this, so this is correct. Okay, now like I said earlier, the reason we went through this with the numbers is to remind you of the process. We're going to be doing something that feels very, very, very similar here. Notice one of the things that can happen is if you aren't being neat as you go along, you can miss bringing down some numbers. It's very easy to do. So when you set up these long division problems with variables, you want to give yourself enough space. You want to space things out more than you really think you need to, so that you can you won't lose things. Okay. Now there are a couple things you need to check on before you start setting up your problem, and this is going to become more and more clear as we get to some further examples. What you want to do first is you want to look at the top and the bottom and make sure that every exponent appears. So if this starts off with a square, I want a first power and I want a constant. If I skip over that x, I'm going to have to make an adjustment, which we will be talking about. We need to make sure that happens in the top and the bottom. They need to be in order, largest exponent down to the smallest, and you can't skip over an exponent. So here I started with 2, I needed a first power and a constant. Here I start with a first power, so I need a constant. Everything is here, and it is in the right order. So we set it up with x plus 8 divided into x squared plus 11x plus 16. And this is what I mean by spreading it out a little bit. Okay? Now, what we do is kind of like what we did up here, where we concentrated on the first parts to make a good guess. Now with the variables, you're not really going to be making a guess, so you're not going to have to worry about making these kinds of adjustments we did up here. Okay, we're going to concentrate just on the first part. What do I have to multiply x by to get to x squared? Well, x squared is x times x, so I need to multiply this by x. So I'm going to put in x right here. Technically, it does not matter if you line up your like terms, but it really will help you a lot. So just go ahead and do that. Okay. Now what did we do up here once we got the number? We took that number and multiplied it here, and then we subtracted from what we have. We do the same thing. I need to do x times this. Now this is a distribution. X times x is x squared. X times 8 is plus 8x. Okay. Now we want to subtract this. And when we subtract a polynomial, we did vertical versions of this in a previous section. You change every sign in it and then you add. Now what should happen every time is these variables should cancel out. Every time. What we have here is 3x. And then just like we did above, we're going to bring down the next part. Okay. Now we repeat the process. What do I have to multiply x by to get a 3x? Well, that needs to be multiplied by a positive 3. So we take this 3 and we distribute it through here. 3 times x is 3x. 3 times 8 is a positive 24. Now we need to subtract, so we change each sign. Your first term should cancel out. We have 16 minus 24, which is a negative 8. Notice we have nothing else to bring down. And if you've been lining up your like terms, you probably don't have any more spots to write anything in. So we're done. We just have to talk about how to write our answer. Just like what we did up here, where we took this top part and then wrote a remainder over what we were dividing by, we do the same thing here. I have x plus 3, and then plus negative 8 over x plus 8. Now, this sign right here messes some people up because up here we don't write a sign, but this is exactly the same thing as 489 plus 3 over 57. It's like this plus is understood when we write things as mixed numbers. It's not understood if we don't write it with variables. Now, technically, since this is a monomial, this could be written like this. But if this had been something other than a monomial, and we will see a problem like that, you really just want to use a plus sign. The plus is always the safest. You know, the minus is sometimes okay. All right.